Hello, my name is John Maxwell and this is AP Computer Science. Today we're going to talk about static methods. We'll also talk about how to set up your first lab in EIMACS, the Chatter Lab, also known as Lab 1. So before us what we have is a class called Slogan, and this class has two private instance variables, phrase and count. But do notice that the count variable has a static modifier. And the purpose again of today's class is talking about all things static. The class looks very common. To set up a slogan, you give it a string, and the string that is provided as a parameter is stored in phrase. The count is increased by 1. We also have two accessor methods, which are toString, which returns the phrase, and also getCount. But notice the getCount method has the static modifier. The purpose of getCount is to return count. And then we have a modifier or a mutator method, resetSlogan, which takes a revised slogan and sets that into phrase. So it's a very common template for a slogan with a constructor that shares the same name as the class and doesn't have a return type. It has a few accessors, which are to return a string form of its representation, and a getCount, which returns the value in the count variable. Going back to the static variable count, I want to point out in a single sentence what that does. The variable count will be shared by all instances of the class. So no matter how many slogans you create, there is only one count variable, and all the slogans that you create share that one variable. And we asked last night, why that's so. Well, first of all, it saves memory. You don't have to have a count variable for every instance of slogan that you create. They all share one. But also, it provides some common information to all the instances of the class. So let's go to a file where we use the slogan object. Well, we'll scroll up. We left it here. And here we create a slogan object, which are object 1, object 2, object 3, object 4, object 5, all in a serial declaration. Notice you can declare more than one variable, separating out commas and setting them all equal to null. An object, when it has not actually been created, is said to be null. Null means that it doesn't have a reference in memory. So it's a null reference. And here we take object 2 and use the new operator to call the constructor, feeding it the string remember the Alamo. And as soon as we do that, we print out object.toString, object2.toString. And we do this for 5 slogans, even testing out the reset slogan from talk is cheap to changing it to love and deeds more than words. And then at the end, we notice here, because it's a static method, we call the getCount method within the slogan class. And in order to say we can do that, a static method can be called by the name of the class. Notice, I'm not using slogan.toString. I'm not using slogan.resetSlogan because it takes an object to call those methods. They're non-static methods within the class. However, I've created getCount as a static method, which means that it can be called by the class. So let's run this and see what it looks like. And it takes some time. So remember the Alamo, don't worry, be happy, live free and die, love and deeds more than words, write once, run anywhere. And the number of slogans created is 5, meaning that static variable count is being shared by all the 5 instances of slogan that we created in this class. Every time we created one, the count went up 1, and then when we asked it to report how many slogans we created, it reported using the slogan.getCount method 5. And that's the way a static variable works, and that's the way a static method can be called. So it's kind of interesting. Notice one little small thing, which is here I'm explicitly calling the obj for .toString method, but here in object 5 I just put object 5 in, and obviously it runs. I do want to let you know a little nuance of it. The systemout.println looks inside the slogan class for a toString method, and when a toString method is found, it will stream out and automatically call that method, so that you don't have to do object for .toString. You can just put the object itself in, and systemout.println will look in the slogan class, find the toString method, and make the appropriate output. So that's something that we'll cover later, but it's good practice to put a toString method in almost every class that you create, and we did so in slogan. Well, moving on to another more famous static method. Here we have the math.pow, and a variety of math methods are required in the AP curriculum. Okay, POW is one of them. It raises the base 2 to the power of 2, and so I would expect 2 squared would result in 4, and that's exactly what happens. Another one that you need to know from the math is random, and asking last night, it returns a double between 0 and 1, not inclusive of 1. So you do need to know it. And this is left over from last night, really, which is how do you generate a number between 1 and 10 if the values are 0 to 0.999? Well, multiply it by 10. So if it's 0.001, you get like some number less than 1. So if you want 1 to 10, you add 1. And if you go 10 times 0.999, you get like a number 9.99. And you add 1 and get 10 and turn it into an int. So that's how you generate a number between 1 and 10. So I'm going to go over and show you the math class. Okay, so not this, but this. If you've gone and ever used the API, the Application Programming Interface, it gives you everything about like a particular class. So another one you need to know is the absolute value. Hey, no problem, give it a number, it returns the absolute value. So the absolute value of -7 would be 7. There's a lot of neat ones, arctangent, arctangent 2, cosine, etc. But you also might need and find handy the max and the min, which returns the max or the min of 2 numbers. Okay, but notice over here, this is why we're here. All of these are static, which means, again, to reinforce the use of a static method, it can be called by the class name. And in fact, that's what we're doing here. Math.pow, math.random. We don't have to create an instance of the math class like new slogan here creates an instance of the slogan class. We just simply have access to them because they're set up as static methods. So that's an advantage to having static methods. They provide a utility in this way, such as the math class. You can see the real advantage of not having to go through the rigmarole of setting up a math object to call the POW method. You can just simply call it by the class name, and there are a lot of utility libraries like math that will operate like that. So there's another advantage to static methods, okay, that work. And let me just run this and show you what the output will be when we raise it to a power. Okay, so it's a little hidden. 4.0 returns a double and it returns 1. Okay, so yeah, math.random chose a number between 1 and 10. Well, that's it for the use of static methods and static variables. Just to re-summarize, a static variable applies and is accessible by all instances of the class, so no matter how many slogans you create, it all shares that same variable. And a static method here, such as getCount, allows the use of that method strictly through the class name slogan.getCount, as you see in the other examples. So that's a summary of static, okay, and hopefully that makes sense to you. Now I'm going to move over to something that applies strictly to my class, and we're going to talk about the EIMACS and the first lab, Chatter. So you move along 1 through 3, 4, and you're doing well, and it tells you, hey, you want to set up Eclipse or NetBeans? And last night I surveyed the class, and only one student was using Eclipse, and no one was using NetBeans, and a lot of people were using IntelliJ, and some people were using Visual Studio Code. And although the instructions tell you that you should be using Eclipse and NetBeans, you can actually use any of the compiler or IDEs that you're using. It starts with downloading this file. So if I download this file, yeah, in a Windows system it'll appear up here and it'll show that it's there. And I'm just going to go into here and point out that, yeah, it's downloaded in the downloads folder, and you can see I've done this a bunch of times. It's a compressed or zip file, okay? So what you want to do is extract it, right? I'm right clicking on it and extract all, and this time you get a chance to extract it to a specific folder, and I don't want it extracted in my downloads. You probably don't want it either. You save your work in a particular place on your computer. So you might want to browse, okay? And you can see that I've already extracted it to the place where I want it in your course, AVOI, okay? So I'm just going to cancel that, but normally you would choose the location and then hit extract right here. So once downloaded, you extract it to the location that you want. So let's go back to Visual Studio Code and show you how to open it. Okay. Certainly the instructions on Eclipse and NetBeans, if you don't have a local computer, they're free, both of them. You can go ahead and follow those instructions. I'm sorry, if you don't have a local compiler on your computer, you can certainly follow those instructions, and I've used Eclipse for many years. It's a good program, okay? But if you're using Visual Studio Code, basically you just go open folder, lab 1, select folder. and it opens for you. And in the long run, eventually, you'll get to a run button, and I will demo it for you just to prove that it does work. Okay, and it takes a while when you first open it up. It's importing and checking for details and doing things like that. Okay. If you scroll through it, you can look and learn a lot from this file, but just don't freak out when you get to step 5 and you don't have Eclipse on the computer. You don't have to actually worry about setting it up that much. Okay, so we're still waiting for it to run. It's down in the corner, building, cleaning, copying resources, etc. So it's just building it, and diagnostics. You can look in the corner. Files 10 days. Oh, please, let's go. Boo, boo, boo. All right. You didn't need to hear me go through all of that. Still waiting. Hello, let's talk. It's a chat program. That's why it's called Chatter. So it's not anything like cheap Chat GPT. And I want you to, not think that like Chat GPT is developed this way. There's certain elements to it that are pertinent. It's worth thinking, how is this related to Chat GPT now? But like, I'm going to go, hello, Uncle Bob. Chatter, I see. Okay. Hello, Uncle. Tell me more about your family. Dog. Tell me more about your pets. No. So you can see that the chat has a response to it. All very well and good. Okay. But I want to take you one other place, which is step 10. In step 10, they tell you, go ahead and create a zip and load it up here. And if you are good with it, then it will tell you thumbs up, we're good. Okay. And so what I want to do is show you how to do that. When you complete the lab, you go back to here and right click or create a zip file, compress to a zip file, and that file, the entire lab 1 folder, gets put in a zip. And I did it last night, so I want to say, where is it? Lab 1, right here. I zipped it. So when I go to here, I can just go to that and upload it, lab 1, and try to submit. And it says your code did not meet certain minimum requirements. Please try again. That means you have to go back into your IDE and fix it. So that's how you download, open in Visual Studio Code, how you zip it to upload it again in step 10. So just a reminder, from last Sunday, we have 2 weeks to complete the lab 1. I do it because you may have difficulty setting it up on your compiler, but it should go pretty cleanly after that. It's mostly a string type problem. The chatbot, ChatGPT, is based on string processing. So if you wonder why we spent so much time on strings in this first semester, it's because strings are the basis of so many programs, including ChatGPT, because at is the pinnacle of a natural languaging process, which is NLP, and manipulation of strings. So this has been this week's class. I hope you have success and reach out if you need assistance. Thank you.